Okay, before we get started with today's lesson, I would like you guys to take a look at two questions. These are going to be covering measures of center, which we talked about in the last lesson. So pause the video, take a moment to find these two answers, and then unpause the video to get the results. Okay, so in number one, this is a weighted mean question. Notice that it's asking us to find the mean cost. So that makes cost our data values or X values. We would enter those in list 1 in our calculator. And then that makes the number sold the frequency or the weights. And we would enter that into list 2 in our calculator. So if we do that, we get an average of $54,566.67. So that would be the average cost of a helicopter. Number 2 is asking us to determine how the three measures of center relate to each other. So taking a look at this distribution, I noticed that it is skewed to the right or positively skewed. So these really high values are going to pull up the mean. So the mean is going to be pulled to the right. The median is going to stay relatively in the center, and then the mode is going to be located at the peak. So that means that the mean is the greatest, the median is left in the middle, and the mode is the smallest. So the mean is greater than the median, which is greater than the mode. It also asks us which measure would best represent the salary. So since that mean is being pulled up by those large values, the median is going to do a better job in representing the middle salary. Again, before we move on with today's lesson, I'd like you guys to take a look at this scenario. A consumer wants to purchase exterior paint to repaint his house. So he collected some data on 2 brands of paint. These numbers are representing the number of months the paint was on a house before it started to fade. Go ahead and find the measures of center for each brand, and then think about what recommendation you would give this consumer as to which brand of paint he should pick, and think about why he should pick that particular brand of paint. Pause the video here and then unpause to hear the discussion. So taking a look at just the measures of center, all of the measures of center for both data sets end up being 35. Well, except for the fact that brand A paint doesn't have a mode. But other than that, all of the measures of center are 35. So just looking at the measure of center does not give us a full picture of what's going on with these two data sets. We would assume, with the fact that all the measures of center are 35 for both data sets, that these two data sets are exactly the same, when in actuality they are quite different. So thinking about a recommendation for this consumer, personally, I would pick brand B paint. Taking a look at the distribution, the numbers are more reliable, more consistent, where brand A, you're really not sure what you're going to get with brand A. Your house could start to fade in less than a year, 10 months. Or it could take 5 years for it to start to fade. It could start to fade in 60 months. But you don't know what you're going to get with brand A. Brand B is, again, more reliable, more consistent. You expect it to last around 35 months. So around 3 years before you have to repaint your house. This takes us into what we're going to be talking about today, measures of variability. So we're going to be talking about how we can describe that consistency in the data or the reliability in the data. There are 5 measures of variability that we're going to be discussing today: the range, the interquartile range, the variance, the standard deviation, and the coefficient of variation. Now, the coefficient of variation is only used if you're asked to compare 2 different variables. So we're only going to be using that on specific examples. If we're just looking at one data set, then we're only going to calculate the first 4 measures: the range, interquartile range, variance, and standard deviation. We're going to have a couple of examples where they're asking us to compare 2 different variables with different units, and that's when we're going to use the coefficient of variation, or the CoVar. Okay, so let's take a look at those first 4 measures. We're going to use brand A paint to talk about how do we find all 4 of those measures. So with range, I've ordered the numbers already for us from least to greatest. So we're going to find the max and the min. So the max for this data set is 60. And the minimum is 10. So in order to find the range, we subtract these 2 values. So the max minus the min gives us a range of 50. The interquartile range is the difference between quartile 3 and quartile 1. So in order to find those quartiles, you're going to first find the median, or cut the data in half. So we saw in the previous slide that the median was 35. The 35 cuts the data into a lower half and an upper half. We're going to find the median of both halves, and these are going to be the quartiles. So the median of the lower half is 20, so that's the lower quartile, or quartile 1. And the median of the upper half is 50, so that's quartile 3. So in order to find the IQR, we're going to take Q3 and subtract off Q1. This gives me an interquartile range for this data set of 30. Now, both the variance and the standard deviation are going to follow a formula. So we're going to talk about the variance formula first. We're going to take each data value and subtract off the mean. We're then going to square those differences, sum those values, and then divide by the sample size minus 1. That's going to give us the variance. The symbol for variance is S squared. In order to find the standard deviation, we are going to square root the variance. In other words, we're going to square root that whole process that we just talked about, taking the data value and subtracting off the mean squared, adding those values together, and dividing by the sample size minus 1. And the square root of all that is going to give us the standard deviation, which is S. S squared is, again, the variance. So in regular terms, the standard deviation is the average distance the values are to the mean. And the variance is that average distance squared. So this is going to take a little bit of space, so I am going to come over to a different slide so we can take a look at how we're going to find the variance and the standard deviation. Okay, so taking a look at those values, I went ahead and copied the data values to the left there. Our first step is we're going to take each data value and subtract off the mean. So for this first one, I'm going to take 10 and subtract off the mean that we found previously, and that mean was 35. We're going to continue to do this for each data set. So 20 minus the 35, 30 minus the 35, and hopefully you're seeing that pattern. So if I do that for each data value in my distribution, 10 minus 35 gives me negative 25. 20 minus 35 gives me negative 15. 30 minus 35 is negative 5. If I continue to do that for the last 3 data values, I get 5, 15, 125. Now notice, if I were to try to average these numbers the way they are right now, add them up and divide by the number of numbers, the negatives are going to cancel out the positives. This would give me a variance or a standard deviation of 0. So a standard deviation of 0 means that all the data values in the list are exactly equal to the mean. There's no deviation. So we don't want to just average these numbers together because we would get 0. So what we do to get rid of those negative values is we square these differences. Then they're not going to cancel each other out. So our next step is to take the data value minus the mean and square those differences. So if we do that, negative 25 squared is 625. Negative 15 squared is 225. For the rest of those values, again, I'm squaring those. I get those values. Okay, now when we add these values together, when I go to average these numbers, they're not going to cancel each other out. They're all positive values, so now we can average these and get a more accurate description of what that average deviation is. So let's go ahead and add those up. I get a sum of 1,750. Now, the formula does say that we're going to divide this by n minus 1. We're not just going to divide this by the number of numbers because we're finding a sample variance. In order to find sample values, you're going to divide by the sample size minus 1. If this represented a population of data points, then we would just divide by n. Since this is a sample, instead of dividing by 6, since there's 6 numbers in the data set, I'm going to divide by 5. So if we do that, we get a sample variance. S squared is the symbol that we use for sample variance of 350. So that is the squared average distance the values are to the mean. The standard deviation is much more useful. It is just going to be the average distance the values are to the mean. So in order to find that, I just need to get rid of that square. So we're going to square root the variance in order to find the standard deviation, which the symbol for standard deviation is just S. So if I square root that value, I get 18.7. So the sample standard deviation is 18.7. So here's my variance. My variance is 350, and my standard deviation is 18.7. So on average, these values are going to vary from the mean 18.7 months. Now let's take a look at an example of coefficient of variation. So again, coefficient of variation is only going to be used when you're comparing two different variables, their variability. So in this example, it says the mean number of sales of cars over a 3-month period is 87 with a standard deviation of 5. The mean commission is $5,225 with a standard deviation of $773. Which variable, sales or commissions, are more variable? Okay, so in order to find the one that's more variable, I cannot just compare their standard deviations. The first standard deviation of 5 is in the unit of number of cars sold. The second standard deviation is in terms of money. So I can't compare these two numbers because they're in different units. So in order to use coefficient of variation, or CoVar, we take the standard deviation divided by the mean and multiply by 100. Because we're taking the standard deviation and dividing by the mean, this eliminates any unit that's on those variables. Multiplying by 100 turns it into a percentage. So we're basically eliminating the unit of sales and the unit of commission and just turning these both into percentages, so therefore we can compare them more effectively. So for number of sales, our mean is 87 and our standard deviation is 5. For the commission, the mean is $5,225 and the standard deviation is 773. So plugging these into the formula, for sales, we would have 5 divided by 87 multiplied by 100. And for commission, we would have 773 divided by 5,225 and multiplied by 100. All right, let's go ahead and find those values. These are both going to be percentages, and then we'll compare them to figure out which one's more variable. Okay, for number of cars sold, I got 5.7% when I did that math. And for commissions, I got 14.8 if I round that to one decimal place, percent. So in order to determine which one is more variable, you look for the higher percentage. The higher the percentage, the more variable the data. So we see 14.8% is higher than 5.7%. Therefore, the commissions is more variable than sales. Okay, why don't you try one of those coefficient of variation questions? So this is asking us to determine whether time or grade is more variable. Pause the video here, find those values for CoVar, and unpause the video to see the results. Okay, for time spent on homework, we take the standard deviation of 6 divided by the mean of 37 and multiply by 100. We get a CoVar of 16.2%. And for grade, we take the standard deviation of 12 divided by the mean of 83 and again multiply by 100 to get a CoVar of 14.4% for grade. Comparing these two values, we see 16.2 is more variable, so therefore time is more variable than grade. Okay, take a look at brand B paint. You try to find the 4 measures of variability: range, IQR, variance, and standard deviation for this data set. Again, pause that video and then unpause to get the results. Okay, we get a range of 20. IQR, we had to find the median of the lower half, which was 30, and the median of the upper half, which is 40. Remember, the median was 35. Again, that's how we split the data into 2 halves. If we subtract those quartiles, we get 10 as the IQR. I'm going to show the variance and the standard deviation over here in this other slide. So the list of the data values is here. We take each data value, subtract off the mean. The mean for this data value, this data set, was also 35. So 25 minus the 35 gave me negative 10. 30 minus the 35 gave me negative 5, so on and so forth down the line. We square those differences. Remember, the main priority or the main reason for us to do that is to get rid of the negatives so that the negatives won't cancel out the positives. So if we square those differences, we get the values in this list here. And we add those up to get 250. And then we divide by the sample size minus 1. Again, there were 6 numbers in the data set, so I'm subtracting by 5 in order to find, not subtracting, I'm sorry, dividing by 5 in order to find the sample variance. We get 50. And then in order to find the sample standard deviation, we square root that value, so we get 7.07. Another option that I want to talk about briefly is the fact that you can enter these values into list 1 in your calculator, which I've already done there. We go to the same exact spot we did for measures of center. So stat over to calc, and it's 1 var stats. And again, I just have the one list. And calculate. The calculator is going to tell us the min and the max. So if I scroll down, I can see the max and the min. So I would subtract those to find the range. It's also going to tell me the quartiles. So again, I'm going to subtract Q3 minus Q1 to get the interquartile range. The calculator does not calculate in this menu the variance, but it does tell me the standard deviation. The sample standard deviation, S sub x, is 7.07. And then I would just square that number to get back to my variance. So the calculator is going to give me the standard deviation, and I'm going to have to square that to get the variance. There is going to be a little bit of rounding error there. Don't worry too much about that. I also want to point out that the calculator will tell us the population standard deviation, which is this Greek letter lowercase sigma of x. So the population standard deviation of brand B paint is 6.45. So that would be if I would divide this 250 by 6 and then square root that. Okay, just some last minute thoughts about properties of the measures of variability. The range, since it uses the min and the max, it is going to be affected by outliers in the data set. The IQR is not going to be affected by those outliers or extreme values. So we say that it's resistant to outliers. It would be the preferred distribution measure if it is used on skewed distributions or distributions that have outliers. It is also used when we have one of those open-ended frequency distributions, like if a class said 50 plus. The standard deviation is also affected by outliers because it uses the mean in order to calculate it. So the mean is affected by those outliers, and therefore the standard deviation is as well. But it is the most useful measure when there are no outliers or skews present in the distribution. And then remember, CoVar is used when comparing different variables. Okay, this concludes our lesson on measures of variability.